Take a look at this together. And I haven't prepared this. I've just kind of looked at this and said, okay, let's try it together. For years, I've called this the 2-minute drill, mostly because I think I first gave this problem during football season. So in any case, let's see if we can actually do this in 2 minutes. Now, the goal is not necessarily to go through the formal proof. The goal is to actually decide what test you would use and gut feeling, do you think it converges or diverges? So, all right, let's get out a timer here. And there we go. Let's lower that a little bit. There we go. Ready, aim, fire. Okay, so first things first, this is a geometric series. You're multiplying by 1/4 to get from one term to the next. So it's a geometric series. R equals 1/4. Because that's less than 1 in absolute value, it's going to converge. How about this one? That one, if you rewrite it as 5 times -1 to the n over e to the n, it's really another geometric series. So it's just kind of in disguise a little bit, but it is a geometric series. R in this case is going to be -1 over e to the n, or -1 over e. That's going to be your R. That's going to converge as well. You could also probably use an integral test there. This next one, what I'm seeing mostly is a 3 over 5n squared. These other terms don't matter so much. Now, when you're looking at convergence, it's really that leading term here that's going to make a difference. I would probably use, I think you could use the direct comparison test. This one looks like it's going to converge to me because we got an n squared. You can compare it to the series 1 over n squared with the limit comparison test, or you can put a 5 in here and a 3 and a 5, etc. But you're going to get a finite limit. Now, if you're going to use the direct comparison test, you've got to be a little bit more careful. I'd probably err on the side of a limit comparison test. This next one should be pretty clear. What's that one? What are we going to use there? P-series. Now, if you say integral test, that's fine. I'll accept that as well. The integral test, I would expect more for this one. Both of these are going to converge. So looking good there, looking good here. This one, the major terms are n over n to the 3/2, and n over n to the 3/2, that's going to simplify, right? What's that going to simplify to? It's going to simplify to 1 over n to the 1/2. So that looks like a p-series. I'm thinking it's going to diverge. But I can't use the p-series test for this. This is not set up as a p-series. So what could I do? Well, I could use the integral test, probably without too much fuss. I could probably use the limit comparison test, is probably the easiest thing to do on that one. You might be able to get a direct comparison test out of there someplace, but it feels like more work than I would need. Last one here. We've got k squared over k squared. That one's screaming out to me that it diverges. Can anyone tell me why? And term test. These terms don't have a limit of 0. If your sum is going to eventually go to 0, then these terms have to at some point get really, really small.
Could you explain the number 6 again?
Yeah, so I just eyeballed it and I ignored the +2 term here.
Okay, so you do the limit comparison.
Well, yeah, you do the limit comparison with this term, but to try and get an idea if it converges or diverges, you can kind of ignore some of these finite terms just to work through in your mind and see if it's going to converge or diverge. Yes?
Could you do p-series as well, or no?
No, this is not a p-series. If it didn't have the +2 in here, then you could use a p-series. The p-series is kind of what I'm using when I'm thinking of this term. I'm like, all right, this is approximately this if you wink and nod at that +2 term, and I know that this diverges. So I am using the p-series tangentially, but the actual problem would do with the limit comparison test. All right. You could probably use the integral test as well.
I think it's a timer.
Is it my timer? Oh, all right. All right, so I didn't make my 2-minute cutoff. I failed. I was like, I thought it was somebody's phone. It was funny. I saw a few of you reaching for your phone. You're like, is that me? Is that me? All right, let's take a look at this next one. You've got something raised to the nth power. We just did something like this the other day. What's that one screaming out for? Root test. Now, once you get rid of that power here, you're left with something which has a 3 to the n over 4 to the n. Ignoring these finite terms, or these constant terms, 3 over 4, or 3n over 4n is going to converge. So I'm thinking that one's going to converge because the root test says as long as the nth root of this term, is less than something finite, it's going to be less than, is it less than 1?
Yep.
Yeah, less than 1, it's going to converge. Brandon, I think I saw you spot on with this one earlier. What were we going to use on this one? Yeah.
Ratio.
Yeah, the ratio test. What's your big tip off on that one?
Factorial.
Yeah, you got a factorial. So ratio test is really well suited to the factorial test. I think that one, actually I think that's going to diverge. Remember our pecking order. Well, let's see. Is that going to diverge? No, I think that one's going to converge. Let me think about it. Yeah, because factorial is going to grow faster than either of these two functions. Eventually, I think that one's going to dominate. So I think that one's going to converge. How about this one? Now, if I didn't have this alternating, it'd just be, something of the form 1 over n to the 1/8 power. By itself, what would you expect about this? Is that going to converge or diverge? Diverge. It's a p-series. But because this alternates, well, let's see. What happens to this term as n goes to infinity? What happens to this complete ratio? That ratio as n goes to infinity, Marlon, where's this going to go? It's going to go to 0. So what's that say about this series knowing that it alternates? It's going to converge conditionally by the alternating series test. All right, so you have to have a decreasing sequence and alternating in order for it to converge. So it converges conditionally. By itself, without the alternating part, it would it'd just be a p-series and it would diverge. So it only converges conditionally, conditioned on the fact that it alternates. Let's move on down to this one. How are we looking on this one? What catches your eye about this one? Nth term test. Nice. Both of these have the same degrees. So apply the nth term test. Now the nth term test can only show divergence, right? If the limit is 0, that's fine. It doesn't tell you anything about its convergence or divergence. Remember, the harmonic series would have a limit of 0, but it diverges. So you got to be careful. The nth term test can't show convergence. Yes, Liz?
Now, if the power was higher, like n to the third over n squared, can we still use the nth term?
N to the third over n squared? Yeah. If it was n cubed over n squared, then yeah.
Okay.
Because the nth term test would say the limit of these terms is going to infinity, therefore the series can't converge. If it was the other way around, if it was n squared over n cubed, then the limit would be 0, but then the nth term test wouldn't tell you anything.
Yeah.
So you'd have to look for something else. So the nth term test should only be used with divergence. Let me just put diverges. Yeah. Diverges. Okay. What do you think we're going to do here? What's this one look like it's set up for? Telescoping. Yeah. Telescoping series. And that one's going to converge. How about the last one? There's a couple, a lot of these have a couple answers. that I would accept. What's one of them? All right, geometric. What's R in this case? Has a negative in it.
Negative 8 thirds.
-8 thirds. And that is greater than 1. Therefore, let's try it again. Therefore, diverges. Now you could, if you really wanted to, you could probably get away with the integral test. It feels like it'd be a lot harder. And some of you might try and just throw up a Hail Mary and say, all right, integral test. And you might be right, but I might ask you to prove it, that you can actually integrate something that you say we could do the integral test for. So be careful using the integral test. I don't think there's going to be too many there. I don't see that one used very often, but there you go. Kind of a nice little workout of all the different tests. Now, you should expect to have to do some of these out completely, all right? If I asked you to do all of these out completely, yeah, you'd be taking up all the time from my afternoon class. So neither of us wants that. So I like this. I don't know, you give me some feedback. Is that a fair?
Solve it on the test.
No, you're gonna have to do some of them. You will expect, a section of these to do just like this.
Okay.
That's why I've continually practiced this. This is like the third or so time we've practiced this in this class before our exam. So I want you to have this skill. And that's in part because as we move into Taylor series, we're going to do a lot of work for our Taylor series problems, and then you have to test the endpoints for the interval of convergence. And you're just going to have to, it's convenient just to be able to look at them and say, yeah, I think this is going to converge or diverge.
Okay.
Because those problems are already long enough. And if you had to do this out completely from scratch and not know what's going on, that would suck. Hannah.
Are there some series we should focus on more, like, comes out than others?
I don't have. I've got a couple favorites in here, but I don't think that there's anything that's going to really dominate in terms of, most of the time just use this one or something like that. I like the ratio test. The root test feels like it's only going to work in these niche situations. Telescoping series, that one should be obvious. Nth term test, that's a good one, all right? I mean, if something's not getting to 0 really, really quickly, or at least quick enough, it's just not going to converge. Integral test is good. Geometric series, that one should be a slam dunk. That one's pretty nice and easy. Let's see, alternating series test, that one's a good one. P-series test, that one's a giveaway. All right, if you get in a P-series, like, Mr. Parent's favorite team won over the weekend. Great. So, P-series is pretty nice. That one's a kind of a slam dunk if you see that one. So, any other questions on these here? Okay. All right. Well done on that stuff. I hope it goes well for you.